Good afternoon from sunny Oklahoma in the United States. My name is Eric Quinn, and I have no idea what I'm doing, but I'm going to try my best to give a tutorial on the way that I have hacked together to get oh, damn it. Here we go. To get our lovely game to actually show the terrain. So we have an example at San Francisco. It's got terrain, and then actually getting this data and formatting it in the way that the game knows to eat it up is actually quite dreadful, but I think I've been able to figure out at least one way to get it, even if it is quite tedious. So bear with me as we do it, but we are going to... oh, I may have broken it. Nope. Yeah, so we're going to do this, and this is like 2/3 done. I did a run through before creating this just to make sure that I could do it. So this is Seattle, and we're going to go through the process of generating terrain data at Seattle, which looks something like this big tall mountain right here being the beautiful Mount Rainier that hangs in the background of the city. So if you look in close here, not that anyone particularly cares, but this would be Elliott Bay right here, and then here's the airport, here is Husky Stadium, and then downtown Seattle is all through here, the Space Needle being right about there. And we can... well, I guess you probably would want to see the picture more than that. Seattle, skyline, Mount Rainier. Beautiful, right? Well, it's a tiny little picture, but here's the city. The airport is like right about here, going that way, and then that is the giant mountain in the background. So Seattle will be a really cool airport to actually have some elevation data, because it does go quite high. It gets pretty tall pretty fast over here in the Cascades. Of course, it's nothing like the Rockies, let alone the Himalayas, but you know, it's kind of cool to be able to see Mount Rainier clearly pictured there. So that's what we're going to try to do here. Alright, so the first thing you're going to need is QGIS, and not an auto-completed search. QGIS, it's like a super dreadful to interact with geographic information system. Actually, I guess I can just read it. Yeah, if you don't know what you're doing with GIS stuff, you're going to hate it, because they have very strange ways to do very simple things. But it is incredibly powerful. I'll definitely give it credit for that. But before we get there, we actually have to get our data. And this is the thing where I kind of hacked something up together with one of my favorite websites, GPS Visualizer. It's actually got a whole bunch of handy tools. So if we go to the calculators there, we can go down to this draw range rings around a point, and that's how we're going to get our data. It's going to generate a whole bunch of points around in a circle, and then we can take those points, find out what the elevation is at each of those points, and from there we can generate our own elevation raster and eventually make contours out of it. So you can actually just punch in any airport. So if I wanted to do Heathrow, 10 nautical mile rings, you just do that, and magically it will find the airport, center it around whatever its defined middle is to be. It's not always going to be the exact middle of the airport, but we're going to make a whole bunch of these rings extending outward and get the elevation that way. And you can actually do multiple at a time. So if I wanted a 5 nautical mile ring, oops, I don't know if it minds caps, and a 10, I just put a comma in between them, and it'll draw both rings for me. So through the magic of Excel, we're going to do 70 miles. Okay, so then we'll go fill series. That'll give us 70. I'll copy it out of here, take it into Sublime, which is the second thing I'm going to use. You don't necessarily need Sublime, but you are going to need something that's a heck of a lot better than Notepad if you don't want to spend hours and hours wasting your time. So a couple cool things about Sublime. This is Sublime Text 3. I can just select all with Control A, and then Control Shift L will give me independent selections on each line, so that I can like type stuff in between them. And what I'm going to do with that is I'm going to type NM for nautical miles at the end, and then I'm going to hit delete to bring them all in the same line and separate them with commas. And at the end I will get rid of this straggling comma, and then you should see I have 1 through 70 nautical miles. So I will just copy that, and I will take that back here, and we're going Seattle, so I punch in the ICAO code, paste that in there, and then just to demonstrate what we're going to get out of this, I will click Generate Map, and here you go. Here's all these rings that it's colored for us from 1 mile all the way out to 70 miles. Now, this is not a particularly good way to do this, but it's the only way that I have been able to come up with. The reason being, each one of these rings has like, I don't know, maybe 100 points around it, maybe 120, because there'd be one every 3 degrees, maybe that's what it is. But yeah, so it's got like 120 points around this ring, and there isn't a heck of a lot of difference. But all the way out here at the last outer pink ring, it's also 100 points. So the data is really, really sparse out here and really insanely, unnecessarily thick in here. There's probably a better way to do it, but this is what I came up with, and it's proved to be better than nothing, although it does have one weird, annoying little quirk that we'll have to deal with later. So if I click, instead of draw map, show coordinates, it'll actually show me those coordinates. Now be careful not to just copy it right away, because if you do, you'll notice it probably hasn't finished. Okay, maybe it has. I had this problem once where it didn't finish generating all of them, and I only got like 5 miles of data. So make sure the page has fully loaded and you've got that green G instead of like a page, and it doesn't look like anything's loading anymore. Scroll down to the bottom, make sure that you're actually seeing you know, that maximum range you were looking for. And you can just copy it out of there, take it into Sublime, and then we have to go, well, I don't really have to do anything from here, but I'm going to choose. I'm going to clean it up a little bit. So I'll get rid of this trailing line, go back up to the top of the file, and then delete these 3 stupid things. Now this stupid stuff is repeated with every new ring. So that's fine with me. I'm going to, actually let me, before I continue here, let me clear out all this stuff from last time. Maybe I can actually move it. Yeah, let's do that. Old. Old again. This is, do not organize yourself like this. This is pitiful. Okay. Terrain. Alright, so we're gonna call this I don't know, what is this? This is I guess just points. I'll call it points.txt. There are going to be a lot of files by the time you're done with this, and it's pretty annoying to deal with, but again, it's the only way I've figured out to get it to work. So back on GPS Visualizer, there's this lookup elevations thing, which is super awesome because it uses all of the different digital elevation model data sets. There's the NED, which is the National Elevation Data Set that was a US thing, and they had a nice one and then a slightly older one, and then ASTER is worldwide, STRM3 is worldwide, I think SRTM3 is newer or something, but basically the way they did it is they went through all the hard part of actually getting a hold of the data, and they store it on their servers, and they will give you whatever the most accurate data is that's available, because there isn't really one that is, you know, super accurate and has full coverage of the whole planet. So this is a really cool way to do it because you don't have to deal with any of the complexity of which one do I get and blah blah blah. You just tell it where to look and it'll give you the right answer. So back on here, look up elevations, upload a file. We're going to upload that points file, and it's important that you don't, it does have to be in this format that GPS Visualizer gave it to us, and that's how we're going to give it right back to them. So points.txt, plain text to leave it as it is, and then we're actually going to stay in metric even though you may notice the scale is eventually given in feet. See, so 1,000, 2,000, 3,000, 4,000, those are feet, not meters, obviously. But the data is metric. That's just the way it's set up. Doesn't make a whole lot of sense necessarily, but that is the way it's set up, and it's just easier to roll with it rather than find it and change it, because who really cares? It's a drop down right here. So metric, plain text, we're good. Convert and add elevation. And this will take, you know, maybe 10 seconds or so. It's actually pretty quick. Maybe a bit longer, maybe 20 seconds. And it's just going to go ahead and get elevation data for all of those points. Okay, there we go. Make sure it's got everything in there. 70. Okay. Copy. Go back in here, and you'll see that the columns we have are latitude, this type, latitude, longitude, and then altitude. You see that it's obviously empty. And then as I paste over it, you'll see that we now have that altitude data in there. And that is, again, in meters. So then from this point, I'm going to do the same thing I did last time. Now that we have all the data we needed from GPS Visualizer, we're actually done with them. So everybody say, thank you, GPS Visualizer, you're awesome. And then back up to the top. And we kind of need to just make this all into one coherent glob that QGIS will then be able to interpret. So all these things, we don't need them. I'm just going to remove all of them, which you can do by doing that, and then click Find All, and it will select all of those individual things in Sublime, or you can just do like Find and Replace and delete it, but you also want to get rid of the line, which is why Sublime is nice in this respect. And then the other thing is we also need to get rid of this. So I'm going to select the 0 nautical mile part, and remember, well, yeah, and this is just another Sublime trick. So we're going to go 1 through 9 because those are all single-digit numbers. We'll delete those first. I'm hitting Control D here to make it select the next instance, and we don't want to select 10 because it's too many. And I'm going to move all these cursors together back to the end of the line before that stuff, and then select through the end and just delete it. And then we'll go down here to the next one, and now since there's only 10 through 70, everything has 2 digits, I can go Find All, that'll select all of them, and do the same thing, and you'll see over here on the right that as I delete them, they all disappear, which is why Sublime is the greatest thing in the world. So just one more scan to make sure we aren't having any missing lines or extra crap hanging off the end. Beautiful. Delete this line, and then we'll also have this weird T thing. We don't want that, so just delete that. And then we also have these spaces, and we want to remove the spaces. Let's see, now how did I do this? Because we also want to get rid of the hanging space. Oh, I guess they're all... This is the nice thing about having data that has trailing 0, so it's always the same number of digits. So what I can do here is I can just select all, Control-Shift-L, go home, and then I can literally just cursor over, delete this, and insert the comma that we need. And then we'll do the same thing over here. Comma. And then, now that I've got all that, if there are any spaces, or I guess they're actually tabs, all of these tabs can just get removed. And then we should be golden at this point, which is really neat. Alright, so then we go back up here. I'm just going to overwrite this points text, because I got no reason to keep the old stuff. This is really what we're looking for. And again, remember, this is metric. That'll be important for later. So now, we open up QGIS, which is where the dreadful part begins. Blah, blah, blah. You can see I had to try this many times and start over and lots of different variations till I was able to get it. So hopefully I'll actually remember what I did, but no promises. So we're going to start by importing that stuff. Layer, add delimited text layer. That's what we created, was that delimited text. So we'll open that file, points.txt, and it is comma separated. You could have other delimiters in there, I guess. I just did commas because that's, well, the smartest way to... Oh, also, I forgot one thing. We do want to have a header line up here. So we'll label it so we know what it is. So this is latitude, this is longitude, and then the last one is elevation. Save. And we'll just quit out of that. Layer, add delimited text layer. Browse, points. There we go. So now it automatically recognizes that the first entry is the first bit of data, and it understands that this is the latitude, this is the longitude, and this is the elevation. So just make sure longitude is the X value, latitude is the Y value, otherwise it will come out sideways, and we don't want that. This is how it defaults, so you shouldn't have to change anything. And we'll just click OK. And there you go. So there's our points, and it looks like it doesn't have anything, but if you right-click on it and hit Open Attribute Table, it will show you what is present in the data. So for this point, which should have turned yellow somewhere, it's probably in the first ring. Maybe if I come out a little bit and select this guy. Yeah, there you go. So he's right there, and those are his coordinates, and he has an elevation of 985.1 meters. So there you go. So it is present. And from here, what we're going to do is take all of this data and actually make it into a smoothed out bit of terrain called a raster. And we do that with this processing toolbox, which is under processing toolbox, if you can imagine that. And it's under Saga, raster creation tools, natural neighbor. Okay, so we will execute this on points. Yep, on points. And the attribute is elevation. That's the thing that we're actually trying to get it to interpolate between. The output extent we're going to set to the layer of points. So that'll just be, you know, the perimeter of the circle. And then the cell size, let's just make sure before we do this. If I right-click on this and go to Set Layer Coordinate Reference System, it needs to be WGS 84. It just does, because that's what all your GPS coordinate stuff are based on. So that's WGS 84. Good. Back here to natural neighbor. Points, elevation, output extent to points. And cell size is going to be 0.0005. 3 zeros and a 5. And that is... I don't remember. It was from somewhere on the internet. I think it's like half like a second, as in like a degree minute second, half a second of latitude or second. I'm not exactly sure, but it's just the number that you want to use. So you click run, and ooh, well, it didn't do this last time. Life is full of surprises, isn't it? Let's see what we got at the bottom. Everything seems to be in order. Latitude, longitude, elevation. I spelled everything right. Oh, it could be because I have this thing selected. It doesn't like when you select stuff. Yet I feel like that's not the issue here. Points. Let's just make sure. Layer CRS. It's WGS 84. Let's also set the project to that. Natural neighbor, points, elevation, use layer. (0.005). grid, save the temporary file, and open it. Okay, I don't believe I did anything different, but this time it's working. So, for whatever reason, this thing, at least for me, it repeatedly complains. It has these two errors here, and then it looks like it freezes, and this is why I gave up on it the first 5,000 times, is because I let it sit here for like 15 minutes, and it was still like this, and with errors chilling there, I figured it was toast. It's not toast. It is working, you just have to let it do its work. With this that I have, these 70 mile, or like 71 mile rings, I found that it takes a little over 15 minutes, so maybe like 18 to 20 minutes or so, and I do have a pretty quick computer. So it might take a while. Let's see, it's 8:23 right now, and we will just unpause when it's done, and then you can see where it's at. Well, I was joking when I started, but I started an episode of The Office, and I was actually able to finish it. So it took, what is that, from 8:45 to 23, that would be 22 minutes. An episode of The Office about 21 minutes for your reference. So, alright, so here we go. This is what we got out of that stupid natural neighbor thing. It is a raster, and we can use that to get our contour from. And essentially what it is it's just a colored image, the colors of which are associated with a particular elevation, so the dark being low and the white being high. So from here, we want to make a contour out of this thing, and that was, it was somewhere actually raster, that's right, it was something self-explanatory. Raster, extract, contour. Almost too easy, and we're going to extract that from the grid, which is the thing that we just created, this thing right here. Output file for contour lines. We're going to put that in here, and we're going to call it contour. Why not? And the interval between contour lines, this is the height at which we're going to draw it. And the way we do it is in 1,000-foot increments. So we're going to do 1,000 feet, except it's not 1,000 feet because our data is in metric. So if we look, 1,000 feet in meters is 304.8 meters. So that is what we want here. 304.8. And very important here, we're going to enable this and call it elevation. If we didn't, as it explains right here, the elevation data is not attached to the contours that we're going to create. They would just be lines. And I made that mistake once, and it was kind of a bummer. So that's checked, 304.8 meters, which is 1,000 feet. Yep, looks good. So we're going to click OK to this. This will also take a bit. Oh, actually it was a lot faster this time, but it was never nearly as slow as the other one. So click OK to all this crap, close this, and you'll see we have these beautiful little pink lines. I can even hide the other stuff, and then you can see that this is really starting to look like what it will look like when it's in the sim. So I don't really need that, and then again here's those points that the data came from. And you'll kind of notice with these points, if you look like out along this line, I turn this off, you'll see there's like these very clear, you know, lines of basically just white noise, these extra, you know, it's really clear down here actually, these extra like circle things that are just totally unnecessary, and we're going to have to clean those out, unfortunately. Let's see, so we made the contour. I used that 20 minutes to also make a list, so I actually knew what I was doing here. Oh, yeah, okay. So, and you can do the second part in any order. I'm just going to go ahead and do it now. So we want to take, select the contour layer, which is the layer that has the stuff in it. We're going to go vector, convex hull. No, not on the contour layer. We're going to do it on the points layer. And we're going to create a convex hull, which essentially means a polygon that just goes around the outer edge. So vector geoprocessing tools, convex hull, and we're going to do it around the points layer. We're going to call it, let's call it, keep going. There we go. We'll call it ring, I guess. That sounds like an outer thing, so we'll call it ring. It's going to be a shape file. Single minimum convex hull. Perfect. Okie doke. Now you'll see it made this this nice little circle thing for us. And you'll notice if you click down out here in the canvas and then hold the shift button, you can kind of move stuff around and zooming with the scroll wheel. So that's kind of nice. Alright, so now we've got that outer ring, and the oh, that's right. I actually don't even need that polycentric because I did it the smarter way, right? Right, okay, so that's good. Yeah, and then the next part, why don't we actually move this down to the bottom, hide the rings, or hide the points, show the contours, and then this is where the dreadful, tedious part comes, unfortunately. So if we look at it, and we go into the contour layer, we can select, using this little select thingy. You usually start with this goofy little thing, and you click and it moves, and it's really annoying. So if we go click the select, we can select any of the individual lines in the contour. And what we're going to want to do is edit those lines such that they are always outside of the circle. In fact, well, I don't need to take the time to actually do that, but I can show you why, which is the thing that we currently have, unless I deleted it. Nope, it's still there. So what we currently have in QGIS is really similar to this, and the problem is that it kind of just follows the lines to the edge of the circle, and it doesn't wrap around the edge of the circle. So that's what we're going to have to do manually to stop this green color is being mapped and drawn on the wrong side. The green should be this part, and instead it's doing the other part because it's just connecting this part where it intersects the circle with the place where it intersects the circle all the way down here on the other side. And so we want to kind of pull that green over here so we get, you know, multiple layers being drawn on top of each other in the place where it's really mountainous. Unfortunately, though, like I said, it is a bit of a pain in the ass. So contour layer, and then this little edit button, and then it'll kind of turn everything all these funny colors, and it'll show you the individual nodes. So you can see this one is not outside, and this one, well, actually, yeah, I guess none of it is going to go outside. Yeah, that clearly didn't work. Alright, whatever. We're going to have to do it the old way unless somebody can figure that out. So we'll put this back on. Unfortunately, that did not work out. So, back to the dreadful way. We'll click this stupid thing. It'll make them all colorful. And then what we need to fix is we need to make sure that everything out here at the edge actually extends outside of the circle. And you can feel free to delete stuff that looks extraneous to you. So, alright, so first we click this toggle editing, and then we'll click this node tool right here. And then you can just click on any one of them, and it'll show each of these nodes to you, which you can drag around. It's very similar to Inkscape, if you've ever done Inkscape. It's just a vector graphic editing tool, basically. So we select a whole bunch of nodes, and we can delete them, and you can select over other stuff, like this line right here that I'm tracing over. You can select over that stuff, and it's totally fine. It'll only affect the one that you're actually touching. And we'll just grab close to the edge, and we'll pull that across the circle. And then we just want to follow that around to find the other end of that, which is down here. You can tell because it's a little thicker. And then we'll take this and bring it out here. Right, and we just want to bring them out far enough such that the line that's drawn between these two endpoints is fully outside the circle and not cutting across the corner like we were seeing in the game. Whatever, you should remember it, or you can go back. So that's the idea. That's what we're trying to do. So I'm going to go ahead and go around the whole circle and do that, and then we'll come back when it's all finished. Alright, so it looks like we're done here. So I've gone all the way around and pulled everything out. So I'm just going to take one last scan around to make sure that everything is definitely clear of the circle here. Now here's one other thing. There's a bunch of these little tiny things that are like barely by the edge and would hardly even be visible. If there's really no point to them, you're probably in the node tool like this. You can click on them, select them, and delete them like that, or I'll just undo that. Another thing you can do is just use this little select tool, and then everything that that your intersection you drag and intersect anything. So I don't have to select the whole thing. It'll select that, and then we can delete it. So I can select both this and those little X's just by going like that, and I can delete them. And that's a really handy thing to do, particularly with these stupid little like piles of fixes, and they're like little X's or whatever. The ones that are by the edge, there's a whole bunch of them that are done because of the way we got the points. So I'm also going to go around and delete a bunch of those, just kind of try to clean up the edge as much as I can. Because the more that we can get rid of data here, the better off it's going to be for people who are playing the game. And I know it's tempting to just be like, well, it's close enough, who really cares? But with something like drawing terrain, it really slows the game down so much to have to draw all of this. So, even if it takes a lot of time for us, making sure that we remove as much as possible so that it runs as quickly as possible is the only thing that's really going to lead to a good experience while you're playing. So another crappy thing that happens that I think I mentioned earlier was that in relation to where those dots are, we have these lines of like weird, crappy bubbles and circles, and I'm also going to go ahead and remove those because they look ridiculous and they aren't realistic. They don't actually represent much. They're just something that kind of affects the way that it was drawn. I'll leave the big ones in because they look kind of cool, but I don't want to have many of them in a row because it kind of just makes the data look like it's fake. Alright, so that seems pretty decent to me. And at this stage, I'm just going to unpress this toggle editing button, and then it'll prompt me to save the layer. And so I will say yes. It'll make my changes, and now we'll see that all of those lines are now sticking out like that. And what we're going to do from here is we're going to turn that turn these contours into polygons, because right now they're just polylines, and we need to turn them into an actual fully enclosed shape, which is why we pulled them out like that. So now we just select the contour layer and go, goodness, what is it? It's, I guess, vector, geoprocessing. What was I doing again? Oh, turning that to polygons. Maybe it's raster? No, it's definitely vector. Oh, geometry. It's vector geometry. Yeah, vector geometry. Here we go. So lines to polygons. And we're going to do that for the contour layer. And we're going to call it contour poly for polygons. And just click OK. And we'll close this. And we'll see that it made all these polygons, which if I turn that ring back on, you'll see that pretty much everything everywhere is going to overlap the ring. So then from here, and don't worry if you can't see your lower layers, that is normal. For some annoying reason, they are drawn like upside down, so the lowest layer, like the lowest altitude layer, ends up being on top. Kind of just is what it is. So then from here, now that we've got, let's get rid of that. Now that we've got these contour polygons, we're going to clip them to be within the circle. And that is vector, geometry, vector, geoprocessing, intersect. So we're only going to keep the parts of the brown that intersect with the blue circle. So contour polygon, and we're going to make it clip to the intersect with the ring. We're going to output, we'll call it contour poly round. It is annoying that we have to keep creating new files for this, but that's kind of just how QGIS works, I guess. Click OK. Click Close, hide the old poly, and you'll see that now, even if we get rid of the ring, we have these polygons that are finally the correct circular shape. And if anyone can figure out how to draw like a non-circle like this, there's no reason we couldn't take a polygonal airspace and actually get that polygon in here, and then do the intersection of this with not the circle, but some other shape, and then only have terrain within the airspace, if that was something that you'd be interested in. But I don't know how to do that, and believe me, I tried. It was all I could do just to get this freaking circle in here. Alright, so here's what we got. And at this point, let's see, I mean, yeah, we should be done. This should have everything that we need, and we can check it by right-clicking on it, going to Attribute Table. Yeah, and we've got a whole bunch of polygons, each of which have actual elevation data at them, points, and yeah, there's really nothing else we need to do at this stage. Don't worry about the colors. The colors are actually native in the game. So now we just right-click this round poly layer that we created, and we go Save As GeoJSON, and we're going to save it right in here as KSEA GeoJSON, or obviously whatever airport you're doing, and that goes in Assets, Airports, Terrain folder. So if I launch the game, you'll see right now the old thing that I had from last time that's in here. Get rid of the tutorial. Looks like this, and oh yeah, actually, yeah. So we aren't quite done. I knew there was one other thing we had to do. Yeah, but it'll be actually good to see it. So this is the crappy unfixed version that we had, and now when we export this from QGIS, and also take this coordinate precision down to only 7 or so. We don't really need that many decimals. It's not like we need to be super, super accurate. We're not modeling like a chair. We're modeling freaking airspace. So you could even go lower than that. It just helps save some size on the file so that the download doesn't take so long. So we'll click OK. It'll generate that new one. There you go. It'll actually everything that you make, it'll show. So this is, you know, the GeoJSON that it generated. I don't really care, so we're just going to remove that, and we'll just look at the original one, because who cares? And when we remove it, it doesn't actually delete it. It's still there. So now we'll go back in here. We'll refresh, and it should show us the file that we just created this time. Okay, there you go. So now we'll see that those lines are actually going out the right way, and you can see, you know, light green getting to darker green, or I guess it's darker green going to lighter green, you know, the progression of colors, and then everything is kind of within itself until you get to this really high point right up here and over here east end of the Cascades. So the only problem is that this is in Chrome, which is significantly better than Firefox. And you can tell as I drag this thing across the screen, I mean, it is just dreadful. It's really obliterating the performance. In fact, Firefox would just about crap its pants if it had to do this, I bet. Let's see. I don't know what Firefox's deal is, but it's just like slow in general. Yeah, holy crap. Yeah, I mean, that's like totally not at all going to work. And this is actually a really easy fix. The problem, which you probably would have noticed while you were editing your nodes, is if I go down in here and look at the nodes here, let's say I click on this one, I mean, look at all of these freaking, like, this line from here to here is straight, and we have like 400 nodes, and it's literally drawing a line in the sim from here to 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 here. It's just doing all this unnecessary work. And conveniently for us, whoops, we can simplify the geometry. So we'll just go straight for the polygon that we had at the end here, and we'll go vector, geometry, simplify geometry. And we're going to do that to contour poly round, and I found that simplifying to 0.005 is a pretty good amount. We're going to save that to a new file, poly round simplified. Click OK. There it goes, and it says it took it down from 287,000 vertices, so 287,000 lines it will have to draw every time the screen is updated, to 13,000, which is still a heck of a lot. But the average video map, let's see, the one I did for Miami was about 6,000 lines in the poll, so it's probably, I don't know, maybe, it's honestly probably about 5,500 to 6,000 lines for the video map. So this isn't incredibly more than that. It is very good at drawing them efficiently, but you definitely don't want to have something like 300,000. That's just craziness. So 13,000 is doable. You could definitely go lower than that if you wanted to. And the reason I suggest that value is because if you zoom in here and actually look at the difference, you can see that with this one, here are the nodes, and this is the that's the round one. Oh, no, right, yeah. So I'm looking at the other one here. So let's stop it. Yeah, so if I look at, here we go. So this is the blue one. So now let's go edit and node thingy. So show me the nodes. So these are all the nodes that are in the original one that had 300,000. And then if we look at this here, and we click on this one, now you can see the difference. All the little X's are the nodes of the original, and then the little square ones that I have selected here are the nodes of the new one. So you really don't lose hardly any resolution, and you save. I mean, look at all these that we aren't drawing anymore. We just go from here direct to here. So that's definitely the way to go. So that's what it did. Let's go ahead and save the simplified one over top of the old one. And we'll just go back here so that we have a reference. This is jiggling the old crappy slow one with insane amounts of resolution. We'll take that down to 7 digits past the decimal again. Okay, there it goes. And then we'll just refresh this. You'll notice it loaded faster that time, and now it moves around a lot better because it has less to draw. Still not the greatest. Firefox is still going to cry about it, I bet, but it's definitely better than it was, and yeah, that's marginally reasonable. It's definitely a step that that we do need to take, particularly if it's somewhere like Seattle that has this much terrain, you know, going on. There's a lot of things to draw because there's a lot of different layers. So that's pretty much it. Hopefully that was helpful. Obviously, one thing you can't forget to do is in your actual airport file, just because you put, you know, that GeoJSON in the terrain folder doesn't mean it's going to show up. You have to go to it and make sure that this has terrain is set to true. Otherwise, if it's set to false, then you may have a perfect one, but it doesn't show up. Well, I don't know why it is showing up now. There we go. So you could have a perfectly good file and it's not going to come up until you actually change that to true, and then you refresh. So that's it. Hopefully somebody can kind of pick up the work and finish what I started, because it would be nice if there was a less manual way to get this done, but at least now we do have some way to get terrain. So thank you very much, and good luck.